New section, we are going to be talking about structures. This is a new concept in C that allows you to group items together, similar to array, but more powerful. This is. I want to talk about what a structure is, how you can create and how you can use a structure. So structures in C provide another tool for grouping elements together. Again, I mentioned they are similar to an array, but they are actually a bit more powerful. If you are familiar with object-oriented programming, if you are programming Java or C++ or any object-oriented language, it's kind of thought of as an object, but only with data members. No actual behavior, no methods. So it's a powerful concept that you will use in many C programs that you develop because you can group different items together in a single name, and those can represent essentially data attributes. And a date usually consists of three variables: month, day, and year. You would create those three variables to store that data. For example, you would say int month equals 9, day equals 25, year equals 2015. Suppose your program also needs to store the date of purchase of a particular item. Well, you had probably have to go and create three more variables for each date that you use in your program. So you can see how this can get very repetitive, and you end up creating a lot of variables. But what you should notice is these variables are logically related. They are all dates. They really should be grouped together. They should almost be their own data type, and then you should be able to create them and access the different elements. You should not have to create three separate variables for every single date. So again, this is where it comes into relation to objects in a class that has three data attributes. So it would be much better if you could somehow group these sets of three variables together. And this is precisely what the structure element does. And it allows you to group these different elements together with a particular name. You can then create different variables of that name and access the elements in that name. The different data attributes, they are really called members. So how do you create a structure in C? It's very, very simple. A structure declaration describes how a structure is put together, what elements are inside the structure, and we usually refer to these elements as member, because you first have to define the structure or declare the structure, describe what is inside the structure, and so you can do that with a struct collection of variables of various types called a structure that you treat as a single unit. Very, very powerful. So by using the struct keyword, all you have to do is provide a name. And this is usually referred to as the tag name. In this example, we have a tag name of date, but you see the keyword struct. That's the keyword that tells the C compiler that this is going to be a specific function. This have a specific functionality that allows you to group elements. So struct is the keyword followed by the tag name. And then you have the left curly brace and the right curly brace followed by a semicolon to end. And then inside there, you can define any types of variable you want. You can even put pointers in there, and those are called the members of the struct. So this is a statement. Again, it defines a date structure that the C compiler will understand. It tells the C compiler that the state function is going to contain three elements: month, day, and year. There is no memory allocation for this declaration. Again, what you are saying is this is a structure that exists. I have not started using it yet, I just said this is how it's going to be defined. This is going to be the date structure, and this is what it consists of: the variable names within the date structure, the month, the day, and the year. Those are called members or fields. Members of the structure appear between the braces that follow the struct, tag, name, date. So tag, name, date, very, very simple syntax to grow these elements together inside of a single name, which is date. And you notice it's different from an array because there is no indices. You are not actually specifying a size. It's not the exact same data type. You can have different data types and you can have many different ones. So how would you utilize this structure? Well, the definition of a date defines a new type in the language. You can really think of it as another type, just like an int, a double, a float. Except this type you define, you can almost think of it as an enum, except an enum only holds one value. This data structure can hold three values, but it's not. Another data type variable can now be declared to be of type struct to date. So what's exactly what they are they would do? You could create a new variable called today, and it's going to be type struct data, and today is essentially going to be able to hold three values. And then if you need to declare more dates, you can create more variables of that same type. And so you no longer need to have three separate variables for a particular purchase date, three separate variables for the current date, three separate variable for a billing date. You can have one variable or two variables of different instances of that actual stack. Again, hopefully you notice how powerful this can be. So this above statement be of type struct date, purchase date. Memory is now allocated because you declared the variable. Memory is allocated for this structure. Memory is allocated for the three integer values of the three members of each variable. So that memory is going to be allocated, and also the reason it's going to be allocated is because there is no pointers in there. If there were pointers in that struct, you would have to allocate memory for that pointer. But since this today's date structure, it's a very simple struct. I'm starting off slow. It contains three ints. Those members are automatically allocated for you, but make sure you understand this distinction from the previous slide and this current slide. There is difference between defining a structure and declaring the variables of that particular structure type. The finance structure again is just telling the C compiler here is a structure and this is the data that's inside of it. But actually declaring a variable of that particular structure type is saying I'm going to start using that structure. I now have memory allocated for the three elements in our example, and I can access those elements and set them. So how do you access the members in a structure? So now that you know how to define a structure, and now you know how to declare a structure variable. You know, need to be able to understand how to refer to those members of struct. You have to access them. If you could not access them to see the values or set values, it would be a useless. So a structure variable name is not a pointer. So you need a special syntax to access to members, because pointers usually contain just the value of an address. And if it is not a pointer, then you are going to need some special syntax. You can refer to a number of a structure by writing the variable name followed by a period. It's usually called like the dot operator, and then after that dot operator period, you follow the name of the member variable inside of that struct. The period between the structure variable name and the member name is called the member selection operator. also referred to as the dot operator. There are no spaces permitted between the variable name and the period and the member name to set the value of the day in the variable today to 25. I would just do something like this, the name of the variable, which is today, and then I would say dot, no spaces in between either side, and then I would specify the name of the element inside the structure definition, which is day. And then I would assign it just like I assign any other integer. I would use the equals assignment operator, a literal constant here and semicolon, very, very simple. If I want to assign the year, I would say today year, and I would say equal 2015, for example. And then I want to access the member values. For example, if I want to access the member value of month to see if it is equal to 12, I would still use that dot met syntax, that member selection operator. So you can use the member selection operator to access the members values. And when you access those member variables, you can use them just like you use other variables. You can use them in arithmetic operations if they are ints. You would follow the rules of that data type. So in this case, we can actually compare that into 12 just using the equals inside of an if statement. And then, for example, if it was equal to 12, we could say next month equals 1. That may be a local variable that we would assign. So let's look at an example here. We are defining a struct called date. We have three elements, integers, month, day, and year. We know that we are defining it because we have the struct keyword and we have those curly braces. And then also notice that right curly braces has a semicolon to end the definition. At this point, no memory is allocated for this structure. In the next line, we actually declare a variable of that type. So we are now allocating memory for a variable named today that contains three elements essentially, month, day, and year of type integer. We can assign data to those three elements inside that struct today by just using that dot member access. So today month equals 9, today day equals 25, and today year 2015. If we then wanted to print it or access that data, we would access it the same way after we assigned it. We would just use that member selection today month, today day, today dot year, and again we can perform arithmetic operation on it because it is an integer. We would use %d, or if we want to format it to 2, we could say %2 or %2d. So this is a pretty straightforward syntax, very easy to create and define the structure and then use them and then access them using the dot member selection operator. How about structures and expressions? Well, you just saw that I was able to access data and using an arithmetic expression, and it's no different when it comes to the evaluation of the expression. Structure members follow the same rules as ordinary variables do. If you have members inside the struct that are integers, you can do the same rules of the other integers. You can apply addition, subtraction, and so forth. If it's a character buffer, you can only do the rules of character buffers. You add and minus character buffers, things like that, usually not. So floats, doubles, all the different data types, you would just follow those same rules when you use those members inside of expression. So here's an example. I say today dot years divided by 100 plus 1, perfectly valid because year is an int, no different than using a regular variable of type int. You just access it differently by using that member selection operator. Now there are variants, there are different ways to define the structure. The one thing great about C, its flexibility. And allows you to define a structure in many different ways. So you may see different syntax when you define a structure. The first example that I showed you is really the one you should follow. You should always have a tag name. And you should define the structure in one place of your code and then declare variables of it in another. But C being it as it is, it's very flexible. You can actually define structures and declare variables in the same line. And you can also define anonymous structure or no named structure. So there's a lot of flexibility. It's a valid to declare a variable to be a part of particular structure at the same time that you are actually defining the structure. You can put the name of the variable at the bottom. I will show you how to do that. Include the variable name or names before the terminating semicolon of the structure definition. And you can also assign and initialize values to those variables in the normal fashion that you assign any variables. So let's look at that. A variation of defining a struct, doing it in the same time as you are defining it, you can declare a variable. So in this case, we defined our struct date, but we also created a variable called today because at the ending right curly brace, that's the name before the semicolon, that is doing both the creation of the variable of type date struct and the definition of the struct date. So in this above instance, you are creating a variable of the structure. We refer to that also as an instance of the structure. It's called today. It's declared at the same time that the structure is defined. So today is a variable of type date. We did it all in one. And you could actually write after you do that today, you could actually initialize those variables by using the brackets and then saying month equals 5, day equals, and so forth, just like you initialize any other integers. Now, again, another way you could create a structure is you could create an unnamed structure. This is a little bit more limited use structure because you cannot do much with it. But you don't have to actually provide a tag name. Remember, the tag name is at the top right after the struct keyword. In the previous example, the tag name was date, but you don't have to provide that date. If all the variables of a particular data structure type are defined and the structure is defined, then the name can be omitted. And what this really means is you are only going to use the structure one time and one time only. So we could just say struct int day, int year, int month, and then declare the variable in the same thing. But you will notice there is no tag name there after the struct keyword. This is just one struct we are going to use one time. So we create the variable today and then we are never going to use it again. And that's really the disadvantage of it and the limitation. You really never want to do this use unless you have some kind of local struct that you use once. But you cannot define further instances of this if you define the structure this way. As a no-name structure and unnamed structure, all the variable of this structure type that you want your program must be defined in the one statement. You could create more than one variable. You could do the today, comma, and then another variable. So you could create multiple variables. You could initialize multiple variables. But this way is a bit limited because after that variable declaration at the bottom, you cannot create any more variables. So there is three ways to define different structure. One way is to define the structure with a tag name and not creating the variable. You create the variable in a separate instance when the memory we allocated. Another way is to create the variable and the structure and at the same time where you would have tag name, and that would allow you to create other instances or other variables of that struct type later in your program. Or this third option where you could create an unnamed struct with no name. and just the variables at the bottom. And again, you can initialize all these whenever you create either the variables just using the curly braces and so forth. So now initializing structure is very similar to initializing arrays. The elements are listed inside a pair of braces with each element separated by comma. No new step to learn here really. The initial values listed inside the curly braces must be constant expression. You can't use variables looks just similar to an array. Here we are creating a today variable of type struct date, and we are saying that the first member is equal to 7, second is 2, and third is 2015, which is corresponds to the month day in the year, because that's the order of how they were defined in the struct. So just like an array initialization, fewer values might be listed than are contained in the structure. You don't have to provide all three. You could just provide two, and that would initialize the month and the day, and it would not initialize the year. So this would set the date 1, month to 12, day 1, date to 10, but it gives no initial values to date or year. You can also specify the member names in the initialization list. This way, you don't have to actually have any order. You can put them in any order you want, and you are not dependent on that. So you could do something like dot member equals value and struct date 1. You could say dot month equals 12. So the initial syntax of this is setting the member inside the curly braces with the dot, and then just assigning the value dot month equals 12 comma dot date equals 10. You need that dot. That dot is important, so don't forget about that dot. You don't need the instance before the dot. So this is just going to set the year member of the data structure variable today to 2015. In the next example, so here we just say, because remember, you can omit some of the other member variables, and in this case we are admitting the month of the day. So we are just going to set the year to 2015. In the previous case, we actually omitted the year and just set the month and the date to 12 and 10 respectively. We can also do assignment with compound literals. Well, what is that exactly is a compound literal? You can assign one or more values to a structure in a single statement using what is known as compound literal. I believe this might only be in C11, but here we have today. Let's assume that we created a struct date today variable, and then we are actually putting inside the parenthesis struct date, and inside the curly braces we are saying 9 comma 25 comma 2015, and this is compound literal. And inside the curly braces we are saying 9 comma 25 comma 2025, and this is a compound literal. This statement can appear anywhere in the program. So as opposed to actually initializing or assigning values using the dot member, you can put this anywhere in the program after you have actually initialized the today's struct. It's not a declaration statement. This is a compound literal assignment. The typecast operator is used to tell the compiler the type of the expression. So you need to those things in parentheses. That's cast struct date. The list of values follows the cast and are to be assigned to the members of the structure in that order. It's order dependent, so it's listed in the same way as if you are initializing a structure variable. Again, the advantage of this is you don't have to assign each member variable individually on a separate lines. You can do it all in one line and say, okay, this is the new line value for this variable today. You can also specify values using the dot member notation as I mentioned. You would just have to do it in one line like this or on separate lines, and this way it sort of looks like the initialization, but you are still doing the compound literals. The advantage of using this approach is that the arguments can appear in any order, so just like previously. Again, the key and the difference of these assignment is it's not happening in the initialization. You are doing it somewhere else in the program to assign new values to that type. So a lot of good information in this lecture. We have talked about struct and how powerful they are and how we can group different elements or different variables into single name. We define that structure. There are various ways to define a structure, and then we also need to declare a variable. Once we have that variable, we can access, assign data to that structure using the dot member selection operator. Then we also discuss some of the different notation and different ways of doing things as well as initialization. We are going to use structures quite a bit. I will have a couple challenges that I will help you get familiar with the syntax, but this is just the start of the structures and talk about how they are related to arrays. We talked about how structures are similar to arrays and that you can store more than one value, but they are different because you can have different data types. You can group them that way, but you can also actually have like arrays of structure. So you have seen how useful structure is and enabling you to logically group related elements together. We have seen that we know how to define a structure with different elements using the struct keyword, using a tag name, and we also know how to create a variable of that type, because that what a structure is essentially is it's a new type of data that you can use, and then you can access elements of a struct using the member selection operator. Well, what about if you want to create multiple structure that is inside of an array? You can do that. So for example, it's only necessary to keep track of one variable instead of three for each date that is used by the program. That's the advantage of the structure. If we wanted to handle 10 different dates in a program, we had only have to keep track of 10 different variables instead of 30, because remember the structure contains 3 variables inside of itself. 10 for different variable is still kind of a lot, so it's really not the optimal way to go. You had probably want to create an array because you had have 10 types of same, just like you had have 10 ints the same. They had just be a structure type. So a better method for handling the 10 different dates involves the combination of two powerful features of the C programming language: structures and array. You can use them together to make it even more powerful. So it's a perfectly valid to define an array of structure. The correct concept of an array of structure is a very powerful and important one in C. So pay close attention. Declaring an array of structure is just like declaring any other kind of array. So you specify the type. It just so happens it's a structure type. So if you want to create an array of structures that are named date, you would say struct date and then the variable name, and then you use the bracket just like you use the bracket for other array. You have to specify the size. So in this case, if you are creating 10 instances and or 10 elements of the data structure type, we could say 10 inside those brackets for the sign. So this would define an array called my dates, which consists of 10 elements. Each element inside the array is defined a buffer type struct date, which contains the 3 members. So essentially what you are doing is you are storing 30 different set of data, 30 different data elements. To identify members of an array of structures, you apply the same rule and you use for individual structures. You file the structure name with the dot operator and then with the member name. Referencing a particular structure element inside the array is quite natural. To set the second date inside the my dates array to 8 August 1986. All you have to do is you specify the name of the array by dates and you specify the index. We are specifying here the second date. Remember, arrays are zero based, so we say one index one, and then if we want to access elements of that array, elements or members of that struct for that element, we say dot month. So this is going to give us the second element in the my dates array, the month value for that struct type, and here we are going to assign it the value of 8. And then if we want to access the day, we are also going to assign the day 8 because it's August 8th. And then finally for the year, we would say dot year equals 1986. This is how you can assign to the second element of the my dates array. And then sorry, the three different variables, because it is of type struct date struct, you should notice that it's really not any different. The only difference here is you have a dot. Normally you just say my dates index 1, and that would be it, because you could only assign one variable depending on the type of that array. But in this case, you can say index 1 with three different variables, because those are the three elements inside the struct. Initializing an array of structure. Initialization of arrays containing structure is similar to initialization of multi-dimensional arrays. Remember, with multi-dimensional arrays, we would follow the specific syntax with curly braces on the outside and then curly braces on the inside, representing each row. The curly braces on the inside were actually optional, but it made it much more readable, and I like to follow that convention. In this example, we are creating my date of type structure date. It's going to be of size 5. In this example, we are creating a my dates of type structure date. It's going to be of size 5, and then we are going to initialize only the first three elements, just like a multi-dimensional array. We have those curly braces inside, and so the first element in the my dates array, which is some index 0 and index element, we are going to say the month is 12, the date is 10, and the year is 1975. And then we are going to do the same for first element. We are going to say 12, 30, 1980. And for the third element, we are going to say 11 elements in the my dates array. Those are not going to be initialized anything. So this will set the first three dates in the array, my date, to 12, 10, 1975, 12, 30, 1980, and 11, 15, 2005. Inner periods of braces are optional, just like in a multi-dimensional area, they are optional as well. But again, sorry, but again, it makes it easier to read, easier to follow those inner braces. I would follow that convention. So you could do this if you want to get rid of the braces, but it's a little harder to follow because now you just have commas separated by commas or elements separated by commas, and it can get very confusing if you are doing a lot of those. You have to map that correctly. Say I am in the fourth element for my fourth comma. Okay, that's going to be the second element of the array. It's harder to follow, so use those inside curly braces. If you want to initialize just the third element of the array to a specified value, you can specify my dates index 5. You are still creating the array here. You are still declaring the variable and setting the size of 5, but inside the curly braces you are saying 2 inside brackets, and you are going to initialize 2 to 12, 10, 1975. And so you will see the square bracket that represent the element that you want to initialize. Then the assignment operator equals, and then inside the curly braces, you are initializing the month, day, and year for the elements inside the struct. So you can specify exactly what element you want to initialize as well. If you want to just set the month and the day, the second element of my dates array, to 12 and 30, you can do something very similar. You just do a comma to separate each attribute. You don't want to actually set the year, so you want to be able to use those curly braces. You could say dot month equal 12, index 1 dot equals 30. And again, this syntax looks very similar to initializing struct variables elsewhere. The only difference here is because it's an array, you have to specify the index of the array, but similar syntax. What about structures containing arrays? Elements inside the structure that contain an array. It's also possible to find a structure that contain an array as a member. This might be useful. It's the most common use is to set up an array of character inside a structure. We use char arrays quite a bit, right, for strings. So it would be very common for a structure to contain a string, essentially a character array. Suppose you want to define a structure called month that contains as its member the number of days in the month as well as the 3-character abbreviation for the month name. Well, that's where we could use a character array. We could say struct month. We know how to define a structure. Again, this is not allocating any memory. This is how the structure is defined. These are the elements that are contained inside of it. Here we are using the struct keyword. We say the name of the struct, the tag name is month. And then we have that left curly braces, and then we specify the elements. We have one element which is integer, represent the number of days. We have a semicolon at the end, and then we have a character array, character name index 3. So size of 3 because it has 3 characters. And then we end the structure with the right curly brace in the semicolon. But remember, characters are arrays and they are closely related to pointer as well as we know that by now, but you can easily have structures contain arrays by just putting them as a member element. And so this sets up a month structure that contains an integer member called member of days and a character member named called name. Member name is actually an array of 3 characters, pretty straightforward. So how do you actually access it? Well, first you have to create your variable. The variable would create memory for the elements inside the struct, and then you had want to just set the proper fields inside the 8-month variable, the character array, because that was the name of it. We had name and number of days. Here it's called a name, and the example it's called a month. Well, a month is the variable type and then name is the element type. So that's correct. So here we create a struct. It's of type month. It's the variable name is a month. We don't initialize it with anything. We immediately set a month number of days of 31. We use that dot member selection operator, and then we want to assign to the character array. We can't assign directly to a character array. You have to do a str compare or something if you wanted to assign everything, and you could say str copy. You could do that. You don't have to use these indexes, a month dot name comma and then JAN is double quotes, or you could do it this way. You access the element of the array via the index. Here we are saying a month dot name because we have to access the name member variable or member element. And then inside the bracket, we specify the index of the array. We'll find it signing the first character in the array of J, second one A, third one N. You would see this syntax if you were doing ints and double and floats. Normally, when you have a character array, you will use a str copy function and assign everything with double quotes. You can also initialize the variable to the same values by doing something very similar when you declare the variable just inside the curly brace. Because it's an array, you can have inside inner curly braces and then the single quotes around each character. And you can set up 12 months structures inside an array to represent each month of the year. So now we can create a months variable, which is an array of size 12 of type struct month, and that can represent each month. And then for each month, we can spend the number of days and the abbreviation for the month. So utilizing these two powerful concepts of arrays and structure is very, very useful. Structures can have elements, so they can actually be a structure of arrays, and elements inside a structure can be an array. And we are going to talk next about how we can use structures to contain other elements like pointers. But you will see that structure can store any type of data in many different types of data. And it's very, very useful to use with the array concept. I hope this was helpful. Again, we will have a challenge to demonstrate some of those concepts and bring up some examples inside the code blocks later. Hello and welcome back. More on structure, particularly nested structure. Nested structure inside structures. Nested structure means structure inside structure. That's what that means. So C allows you to define a structure that itself contain other structure as one or more of its members. It's a pretty neat concept here. You can have structures inside of structures. So you have seen how it's possible to logically group the month, a day in the year into a structure called a date. We have been sticking with this example of date. Well, what about if we want to actually group time, the hours, minutes, and seconds into a structure? That seems like that would be useful as well. So here we would have a structure called time, and it's very similar today structures. It contains three elements. We know the name of the structure is time because it follows the struct keyword, that's the tag name, and then inside the curly braces we define our elements, our data types, and the names of our variables. And we know how, now that we can also put an array in there if we wanted. But in this case, we don't nested need an array. We just need three integer. We end the structure with the right curly brace and the semicolon. What about though? In some applications, you may want to actually group both the date and time together. It would make sense, right? Because the date and time are logically organized or logically together, right? They are logically grouped. So you could set up a list of events that are to be occur at a particular date and time. So this might be a very useful case where you want to use a nested structure. So you have a convenient way to associate both the date and the time together. We can define a new structure called, for example, date and time. This would contain its members, two elements are date and time, which are both structures. So we now have a nested structure. We have a structure named date and time that contains two other structures. Something like that in the syntax is very similar to creating other structures. The only thing difference here is inside the actual structure as the element's name, you have the struct keyword, the name of the struct, and then the available name. So in this case, we are creating a date and time struct, and we have two struct, one's the type date and one of type time. Two variables date and time. The first member of the structure is of type struct date, and it's called SE date. The second member of the date and time structure is of type struct keyword time, and it's called the time. Variables can now be defined to be of type struct date and time. We don't have to create separate variables for date, separate variables for time. We can create one, and that structure is going to be stored both the date and the time. We would do that just like this. We would use a strong keyword to specify the type of the structure, date, and time, and then the variable name. In this case, they are going to store events. So we say event when we want to access the memories in a nested structure. Again, pretty straightforward syntax. All you have to do is reference it like any other member. You have to use that member selection operator. So you would use it pretty much a number of times. So if we have a structure named event and we wanted to get the date, we say events date because that's a member of that date and time struct. Now, if you wanted to reference a particular member inside of a state, again, you would use the period file by the number name that would be tagged on the end. So this below statement is going to set the month of the date structure contained within event to October, and it's going to add 1 to the seconds contained within the time structure. So we say even state and then another dot because we want to access the element of the state variable. We wanted to access month and we are going to assign month 10. So there is multiple dots there, and all this is saying is you have a struct named event, and because of our declaration before we said it was of type date and time, inside there you have a struct which is just a date struct. You want to access of that date struct the month member. So say you dot months to dots, and then if you wanted to change the second increment by 1, we can just say plus plus. We can just use that pre-implementation operator plus plus event as timeout time point seconds. We have to include those two dots, and second is an integer, so it's just going to add 1 to it. Very straightforward. The event variable can be initialized just like a normal structure. If you wanted to set the date in the variable event to February 4, 2015 and the time to 3:30, you would say start date and time event. You would create it just like normal, and then you had have those curly braces to specify the different struct initialization member. So on the first curly brace, we are going to initialize the date. We are going to initialize the month to February, the date 1 and the year to 2015. And then we end the curly braces and we put a comma after those curly braces, and then the second, which is kind of it looks like a multi-dimensional array initialization. We say the time is going to be equal to 3:30 with 0. So 3 hours, 30 minutes, 0 seconds. You can use the members names and initialization just like all of our other initialization rules. This would be beneficial because you don't have to specify the order. And here we just create the event, and then inside the curly braces, we use the dot operator. We say month equals 2 days equals 1 year equals 2015, and that is only going to specify the date initialization. If we wanted to specify the time initialization, we just again use the dots for each member name dot minutes, and we could switch the order around, right? We can say dot second SQL 0 by 1, and then minutes equal 30, and then hour 3 be last. The order does not matter. And then we end it with the semicolon and the curly braces. Now that we know, we can have nested structure. What about an array of nested structure? Now we are really getting into it. Yeah, it's possible. You can set up an array of date and time structure, and date and time contains two structures inside of it. Users do it just like another normal syntax. You have to use those brackets to specify the size of the array. When you declare the actual structure name, you have to specify the of type date and time, just like any other structure. The array events is declared to contain 100 elements of type struct date and time. Fourth date and time contained within the array is referenced using the usual index of 3 or index 3 or subscript 3 inside those square brackets. So to set the first time in the array to noon, you would say events index 0 dot SW time, because remember SW time is pointing to the time struct, and then you have to access the elements in the time struct, which is hours. So you use another dot and you say 12. It looks very similar to the previous declaration or assignment, I would say, but instead it has that array index 0 inside the square brackets. If events was not an array and you just wanted to access the single structure or the R structure of time, you would just get rid of the brackets. So the arrays do not really complicate anything. You just have to be really familiar with those square brackets and the indexes here. We are getting the minutes to zero event index 0. So we are setting that first element and then we are setting the seconds to 0. Now if we wanted to declare a structure within a structure, you can define the date structure within the time structure definition. So this is another category of flexibility. We don't have to necessarily have the date and the time structure defined somewhere else. We can define those structures right in our date and time structure. So here would be an example of just defining the date structure inside inside the time structure. So here we have a nested structure, but we actually define it inside the definition of time struct. So we say struct time with the tag name, and then inside the curly braces, we say struct date. That's perfectly valid. And you will also notice that the end of the start date before the ending semicolon, we are creating a variable called date of birth. And then after we create the start date and its element in a variable date of birth, we specify the elements of the time start, hours, minutes, and second. So that is perfectly valid. So you should probably notice the limitation of the struct date is only going to be defined in there once with a variable name DOB. You will not be able to use the date structure anywhere outside of this. Unless you use an inside time, you will not be able to use date by itself. So the declaration of the date struct is included within the scope of the time structure. Definition scope refers to how you can access things because the date structure is in the scope of time. You cannot access it unless you create a time variable, time struct variable. You can't just say struct date by variable name because you don't have access to that. So date does not exist outside of the time struct. It's impossible to declare a date variable external to the time structure. The only time you can ever use a date structure variable is when you create the time struct, and it will automatically create a DOB variable for you. So this is somewhat limited, but you could use this in a case where you only need the date when it's associated with the time. The date should never be by itself, and then you would do it this way. So another knee concept, a concept of providing a structure inside of a structure, very, very basic, and the syntax is pretty simple. You will get used to these pretty easily. Adding the array to a structure that contains a structure, you just use the square brackets in the index. Nothing really changes there. And then you can change the format a bit. If you only want a local nested structure, you can define it right inside the other structure definition. So we are really becoming experts here with our structure type. I want to talk about the last couple concept. Particularly, I want to show you how you can create pointers inside a structure, which is useful. And then we will do some challenges and exercise, and it will really get you really familiar with this. Side of a structure be a pointer, and then we can also make our structure themselves be pointers. Two very useful concepts. So structure is important here. C allows for pointers to structures. So when we create a variable of type structure, we can create it as a pointer. Pointers to structure are easier to manipulate than that structure themselves. So again, it's sort of a notational thing, make things a lot easier, and it's also more efficient in some older implementation of the C language. A structure cannot be passed as an argument to a function, but we know that a pointer can. So this is another reason why you want to have a structure to be a pointer when you declare it, because then you can pass it around in older version of C. You can pass it as an argument to a function. Even if you can pass a structure as an argument, passing a pointer is more efficient. We know that that's more efficient. We have talked about this in the past. So how passing important can be more efficient. In this case, it's even more efficient, because if you are passing in a entire structure, if the structure is large and it contains a lot of elements, you are copying all the elements in the structure to that parameter. If you are passing a pointer, just copying the address, so it's even more important with pointer as argument that are structured, because structures can be large. So many data representation use structures containing pointers to other structures. You are going to see this a lot in all of your C programs. Structure that are pointers, and for the regions we mentioned the fact that you can pass them as parameters. And older versions to see, and it's also more efficient because we do everything by pass by value, which is copying. Much more efficient to copy an address than copying all the elements of this large structure. So declaring a structure as a pointer, pretty straightforward. When you define a variable to be a pointer to struct, you just use that string after the type of the data. And we said that structures are really a new type. In this case, our ever important data structure, we just say struct date and then use the struct date pointer, and you will probably want to initialize that to null, because remember, when you say struct date pointers, date struct date pointer, that does not allocate any memory for it, creates memory to store the actual pointer. It's not creating memory for the data inside of it. So you could either assign to this date point or the address of another struct date, or you could allocate a memory for it somewhere else, or you could initialize it with some data that way as well. So the variable data date pointer can be assigned just like other pointers. You can set it to point to today's date with the assignment statement. So if we already had a declaration of today's date, we would just use the ampersand to get the address of it. So we create a normal date structure and it's today's date. So that would create memory for the three elements, and then we create our pointer and we just assign it the address of the other date. Pretty straightforward. We have done that with regular data types. It's not different when you do it with structures. You can then indirectly access any of the members of the data structure pointed to by date pointer. So we would need to do something like this. If you wanted to access the element of the day pointer structure, you would have to dereference it first. And so it probably be useful to put it in parentheses. So it's very straightforward. You have to dereference the date pointer to get the value of what today's date is pointing to. The value of the address of today's date which it's pointing to in order to set particular values. So you would dereference it and then do dot day equals 21, and that would assign 21 to your day pointer. Now the above is just saying whatever today's date is pointing to, we want to access that value and set the day to 21. In this case, the parentheses are required because the dot has a higher precedence than the asterisk. If you don't put the parentheses in there, it gets skewed up because it would try to do the dot first before it actually got the pointer to point it to the date. So it would try to access date with a null pointer essentially. And so by dereferencing, you are getting the value. Now, when we use structs a pointer, if we wanted to test the value of months stored in the date structure pointed to by date pointer, we could do something like this. We dereference the pointer, put in parentheses, so it takes precedence over the dot, and then we say dot month equals 12. It's perfectly valid syntax, but it's a kind of a little cumbersome. So C has its own syntax. So you don't have to dereference everything and put it inside a parenthesis for a structure. When you want to access what the structure is pointing to, you don't have to dereference it this way. There is a special operator that exists in C for structures of pointers, and it's the dash greater than. It's a dash followed by the greater than sign. And this allows you to not have to dereference the pointer. So instead of doing star x inside parenthesis and then dot y, you can just say x dash greater than y, because x is pointer. You don't have to reference it with you want to access the element inside that structure, whatever you are pointing to. So you are going to see this syntax all over the place. You are not going to see the parenthesis and the dereference. It's perfectly valid, but you are typing in more characters. It's much more efficient to say, just say x dash greater than y. So the previous if statement up here, instead of dereferencing inside the parenthesis, all you have to do is say if date pointer dash greater than month, and it's somewhat intuitive because the dash greater than is sort of saying it's pointing to something, and so date dash greater than month. So date pointer is a pointer, and that's why you use the dash greater than. Now, if that was a nested structure, you would do the dash greater than to the structure, and then you had have to do a dot after that to access the elements of the nested structure. Double arrow. But because day pointer is a pointer, you have to use the dash equals or dash greater than. So here is an example. We are creating our struct date. We have three elements. Then we are creating our pointer, date pointer, and we are creating just a regular variable today. We assign to our pointer the address of today, and then to assign actual elements of this struct, we just use that dash greater than, and then we can print it out. So let's look at this in code blocks and see how this works. So I'm going to put this example in here, and typically when you define structures, you define them outside of a function, because then you can use them in any function. It's kind of like a global, but remember that when you define the structure, you are not actually creating any memory. So you still create the variables as local variables or pointer, but the actual definition is outside the function. So if you want to use it, you can use it in any function. So here at the top, we have created a new struct of type date or name to date, and it actually so here at the top, we have created a new struct of type date or name to date, and it contains three integers. We ended with a semicolon. We then create a couple variables inside the main, one which is just a normal variable struct date today, and then one that's pointer. We know that it's a pointer because it has the stress before it. We know that a pointer, when you create a pointer, it only creates allocates memory to store that address for that value of that pointer. So we have to actually assign it an address, which we do with ampersand today, because that's actually create a memory report. So now date pointer is going to point to whatever today is with the address of today. We can then start assigning date to it by using the dash greater than very useful symbol and just assign a data like anybody else, just use the assignment operator. And then when we print it out, you will notice we don't have to dereference it to print it out. We can just actually say the data types for this format specify here percent, here percent, same for integer, and then we just use dash greater because that is actually doing the dereferencing. Remember, now we could change this and this would be valid. We have to put in parenthesis and then we have to say the dot month. Either way is fine, but get used to the dash then greater than because it's better syntax. And now when we build this, you will see it print out the date pointers values and they are all set to 925 and 2015. And so it says today's date is 9/25/15. It was formatted to print out that way. Pretty straightforward stuff. Just remember that dash greater than, that's a new syntax for pointers to struct, but everything else here is just normal. We know that pointers have to have a store address, so we know we have to either allocate the dynamic memory or we have to assign it an existing struct. Let's go back and talk more about structs and pointers. Now, let's talk about structs that contain pointers. We know how to create a pointer for a structure. We could allocate memory for that pointer if we didn't want to. Assign existing address of an existing pointer. But you can also have elements inside a structure that's pointer itself. So pointer also could be a member of a structure. We don't have to use that character array, so we could say struct. We could name it in pointers and then we could use here in this example, we have two integer pointers p1 and p2, perfectly valid syntax to do that. So a structure called in pointer is defined to contain two integer pointers. First one is called p1 and the second one is called p2. You can define a variable of type struct in pointers just like normal struct in pointers. The variable pointers can now be used just like other struct. Pointers is not a pointer, it's int pointers. It contains two elements inside its struct that are pointers, but pointers itself is not an actual pointer. So pay attention to that. It's a structure variable that has two pointers as its members. That's different. So if we wanted to access the elements inside the pointer variable, which is in pointers, we don't use the dash greater than because pointers is not a pointer, it's a struct. We would use the dot to access p1 and access p2. So in this example, we create our structure, we create a variable. It's not a pointer called pointers, and then we create two integers, one equal to 100 and i2, which is not initialized. Now p1 and p2 are pointers, so they have to contain valid memory address where the address have been memory allocated. And that's what into I1 and I2 is doing. When you declare the integer variables, memory is being allocated for those integers. And so by assigning the address I1 and I2 to P1 and P2, that's perfectly fine because I1 and I2 have memory allocated for because they are integers. Now, if the integer pointers were not integer pointers, but they were character pointers, then you have to allocate dynamic memory. So now we just are using integers. So we assign the address of the two integers to P1 and P2. We can now say star pointers P1 equals 97, negative 97. Why do we have to dereference it there? Because pointers.p2 is what we are referencing pointers.p2 is a pointer, we are not accessing an element of a structure. We are dereferencing all of pointers.p2. And we are going to assign that the value of that whatever that's pointing to -97. So notice the difference there. We are not creating a structure pointer, we are creating a regular variable pointer, but it contains two elements that are pointers. So if we wanted to assign to those two elements inside of the structure, we have to dereference them using the indirection operator. And that's what we do there. And then in our two print statements, again we want to print out the values of what P1 is pointing to. So we dereference it same with P2, and then we want to also print out again the values what pointers is pointing to. So in that first one, we are seeing I1 equals percent I comma pointers dot P1 equals percent I. So the first one inside the double quotes is just printing out that actual text. It's not dereferencing anything. After the comma is when we are doing the dereferencing. We are first printing out I1, which is 100, and then printing out pointers P1, which would be 100. I2 is actually going to be -91, 97, and after we assign it to P2. So what about character arrays or character pointers? In the previous lecture, we talked about how you can create a character array as an element inside of a pointer. But what about character pointers? Should we do something like first and last have a character array, or should we just do something like first and last with character pointers as elements? What is the better option? Well, we'll see. It really again a notational thing, but there are advantages to using the pointers. So when we create pointers to characters inside of our elements, it's usually a little bit better, but you need to understand what's going on here when you create array elements. Char array as an element or a pointer as an element, both are valid, but there's big difference. So if we say struct names v or pp, or we say Talia Summers, and then we say struct pointer name. So remember, struct names contains the character array. Struct pointer names contains the pointers. When we say we here are initializing the pointers equal to bread and falling. So, and then we print them out. We are going to print out the first element, which is a character A and VP, and then the first element of trees, which is a pointer to first. So the struct names variable V. What's happening here is the strings are stored inside the structure. The structure has allocated a total of 40 bytes to hold the two names. They are character arrays. That's what happening when we create character arrays inside of a pointer. We are allocating 40 bytes to hold those two names, 20 and 20, for the pointer names variable trees, whether we have to pointers first and last. These are strings that are stored whenever the compiler stores strings constant, because the structure hold the two address. They are pointers. Pointers contain what value, that's an address. So all it's going to do is allocate two pointers inside that structure. That's 16 bytes for most point systems. Pointers usually 8 bytes or 4 bytes. The struct P all name structure allocates no space to store the strings because it's only allocating space for the pointers themselves. Pointers have values that are addresses. The addresses that it's pointing to, there is no memory allocated for that. So when you create those two pointers, there is no memory allocated for those two pointers. It allocates no space. So it can be used only with the strings that have had space allocated for them elsewhere. Whenever you have pointers inside of a structure, you have to use malloc or calloc. Otherwise, they could be stored wherever string constant is stored. And that's the big difference. So the pointers and p name structure should be used only to manage strings that were created and allocated elsewhere in the program. You do not want to assign data to that unless you have dynamically allocated it or that has been allocated somewhere else, maybe by an existing struct or something. But typically, you are going to want to malloc those pointers again, very different. You are allocating 40 bytes for these two characters arrays inside the name struct. For the p name struct, you have two pointers. There is no memory allocated for that when you create a variable of that type. It's just creating memory for the two character pointers, which is 8 bytes each. To actually allocate memory for what first and last are pointing to, you have to do a malloc. So one instance in which it does make sense to use a pointer and a structure is to handle strings is if you are dynamically allocating that memory. That's usually when you use it because other permitted data types are automatically going to allocate the memory for you. So you want to use a pointer to store the address. This has the advantage that you can ask malloc to allocate just the amount of space that is needed for a string. We talked about the advantages of dynamic memory allocation when you create things statically at compile time. You are only going to create a specific number of bytes. What happens if you need more bytes? You are screwed up. Your program not going to work. You have to go back and recompile with dynamically allocated strings. You can you can create just as much memory as you need, which make it much more efficient in the program. So you are going to use malloc on any pointers created inside of a struct. So in this case, you have a struct named name count. You have two pointers, character pointers, fname and last name, first name or last name, and then you have an int letters. The two strings inside here are not stored in the structure. We only create memory for the pointers which contain addresses. We want to create memory for fname and iname for what the pointers are pointing to. So we want to store that in a chunk managed by dynamic memory allocation, which is using malloc. The address of the two strings are what's stored, not what they are pointing to. So addresses are what string handling functions typically work with, which is good, and that's why you want to use pointers in there. Because then you don't have to do that, then you can just pass them around a lot easier. So here is an example. We have a function called get info. It takes a pointer and we can pass that pointer around very easily. Now we also are going to create another or for our pointer array that we are being passed to it. We are going to allocate memory for it. So you will see that we create a character called temp, and then we store some data in that temp. We ask the user to get something. We are not familiar with the sgets, but it's the same as the get saved scanf a little. Then we allocate memory for fname inside that pointer, and we do that just like we allocate memory for any character we call malloc. We pass in the name of the bytes. In this case, the str length of 10 plus 1 for the null terminator. And then remember, malloc turns a void star. So we cast it to character star. But this is critical right here. This malloc call is necessary for any structure that contain pointers. Now we pass this pointer in and the pointer never had a memory allocated for it. So we are allocating memory inside here. We can then do our copy very easily. we can copy temp to fname of our structure pst that was passed in the parameter, and then we can have them enter their last name. We can malloc more memory for the last name and the stored in the last name struct variable. This is what you are going to need to do when you are pointers to characters inside your characters structures. You have to do the malloc because again, those pointers only store the address. They allocate enough memory to store an address, not enough memory to store a string. So whatever that address is pointing to, you have to allocate memory for that. And you do it just like normal with the malloc. The only difference is here you use the dash greater than sign to access the actual element inside that struct, which is character pointer. So you can assign it to it, and that's doing the dereferencing. So you will want to play around with this stuff. This is very common for character pointers inside a struct. We are going to have a challenge where you are gonna need to do this, but play around with this code, go inside code blocks, start allocating memory for strings or characters pointers inside of a struct, and see how you then can use str copy to actually put data inside there. But you first have to allocate the memory before you reassign. If you are doing constants like in the previous example, who knows where that memory is allocated? So again, a lot of important concept presented in this lecture. This idea of a structure that is a pointer in this new syntax where you can use the dash then greater than as opposed to using the indirection operator. Very nice. And then actually having element as pointer, and now you have to allocate memory. Structures is how they are related to functions, how you can pass structures as an argument to a parameter and a function, and how this is more efficient as well. So structures as arguments to functions after declaring a structure named family. In this example, we are going to create a named family. How do we pass this structure as an argument to a function? So we have this structure called family. We have a bunch of character arrays in here, name, father and mother. And then we have an int age, that's our structure definition. We know it's a structure because the struct keyword is there followed by the tag name. We have our curly braces and so forth. Now, how do we actually pass that structure to a function called siblings? Well, you would do it just like you declare the structure. You would say that type as the parameter name. It's really straightforward. So in this case, we have Boolean siblings. Siblings is returning a Boolean and it's taking two parameters, two struct parameters. You have to identify the struct type, which is type struct family. Now in more advanced C, you could actually do a type def on this struct and name it something else. And you could shorten the name here, but we have not talked about type defs. That would probably be better, but this is really how you would need to do it. You would have to define the entire type, which is struct family and then the variable name, just like any other parameter. So here we are passing in two parameters, member1 and member2. They are both of type struct family, the inside of our function. If we want to access members, we access member just like normal member 1 and member 2. They are not pointers, so we don't use the dash then greater than. We only do that on the pointers because we need to dereference them to see what they are pointing to. Because they are not pointer, we can just do dot. So member one dot member two dot member mother, member one dot mother and mother dot member mother are character arrays, and character arrays are pointers essentially. So we can pass them to the str compare. Str compare is going to return equals if they are the same. So what we are doing here is we are checking member one mother and member two mother are the same, and if they are, we are going to return true if they are same, because if the both the same name and the that really would be the last name, then they are siblings. Pretty straightforward, easy to pass argument to function as long as the function declaration has that type struct in there. So this function again two parameters, each of which is a structure of type family. What about if we want to have pointers to structures as function arguments? And I mentioned earlier, this is better to do because we are doing pass by value, and see, when you do pass by value, you copy. If you have a structure that contains a lot of data, a lot of large structures as arguments, you have to copy everything in that structure to the actual function. So that could take some time to copy those large structures over. Well, if you have a pointer, all you have to do is copy the structure address, which is much quicker. So pointers to structures are used as parameters and functions to avoid memory consumption and the time it takes to copy all the structures. Now, if you have a small structure, no big deal, but definitely want to use pointers and structures that are big. So in this case, what do? You still specify the name of the type of structure. You just put the asterisk beforehand, very simple. And if you didn't want any of the data inside the structure to change, you could use constant before the structure type. If you don't want the address to change, you would put the constant after the struct family pointer. But here we are doing the same thing, but now we are going to access it differently, because now that it's a pointer, we can use the dash greater than that new symbol to access instead of using the dot. We don't have to use the dot here because remember, pointer you have to dereference first, so you have to put it in parentheses. It's more syntax to dereference the pointer, then you have to put the dot outside the parenthesis because it has higher precedence. Much easier to use the dash than greater than. Dash and greater than mother. Dash and greater than mother, they are both pointers. They can be passed in the str compare. If there is the same, return true, otherwise return false. Pretty straightforward. You can also use the const modifier as I mentioned. What the structure is pointing to, then you put the const before the pointer. You could put the const actually before family as well. In this case, family has a type def. So here it would really the construct family or struct family const pointer, and then again access the same way. You are not modifying anything. You are good to go. Compiler is not going to complain. You can also use the constant modifier if you don't want to allow any modification of the address itself. Any attempt to change these structures will cause an error message during compilation. So here you would say family star and you put the constant after the star. And what this is saying is you cannot change the value of p member, the value of the pointer, which is an address. But again, this is not very useful because when you pass by value, you are actually passing in a copy of the address. So this is redundant, duplicate. You don't need to do this, but you can. And in this case, you are just, you want to be able to change the address of what P member is. And in this case, you are just accessing the data anyways to see if they are equal. The indirection operator in each parameter definition is now in front of the constant keyword. That asterisk, it's not in front of the parameter name. You cannot modify the address stored in the pointers because it's after the asterisk. If it was in front of the parameter name type, then you want to be able to modify the actual what it's pointing to. If we had that indirection operator in front of the parameter name, what that would in the constant before it, that would mean you want to be able to modify what it's pointing to. This is just saying the address. So you cannot modify the address stored in the pointers. So it's the pointer that are protected here, not the structure to which they point. Just like constant and other pointer parameters, no difference with the struct. If you want to return a structure from a function that's a pointer, the function prototype has to indicate this return value in the normal way in the declaration. So here you had have to say struct to date my fun pointer or not pointer. It does not matter. This is a prototype for a function taking no argument that returns a structure of type date. Very easy to return a structure from a function. And what is the value of this? Well, now we can return more than one element or one data item from a function. If you are returning a struct, you could return 10 values, 10 different data items. How cool is that? The struct allows you to return more than one from a function. Very, very valuable. So it's often more convenient to return a pointer to a structure as opposed to just a structure. When you return a pointer to a structure, it's created on the heap. Because all pointers are created on the heap, this means it's going to be around a bit longer, and this means you can delete it and manage it at arbitrary times. So in this example, we are creating a struct named funds, contains a character array named bank, contains a double, another character named saved of a particular length. Just assume the fun length is equal to 50, and then it has a double saved one. We have a function called sum which takes that structure as a parameter. And all we are doing is inside that is we are returning the bank fund from the first structure plus the save fund. And that's going to return the amount that they have in their bank. In this example, sum is just a double. We are not returning a pointer. We are just taking a pointer as a parameter. And so in our main function, we are creating a structure variable called stan of type struct funds. We are initializing it with some values, and then we are printing out the total of calling sum. And we just pass this structure like we pass any variable. We don't have to dereference it. It's not a pointer. We don't have to really do anything special. We just make sure that in the function declaration we have that struct type there, but everything else looks normal. A couple reminders. I mentioned earlier that you should always use pointers when passing structures to a function. Why? Because remember, older version of C don't allow structures to be passed, but they do allow pointers. So you can avoid any kind of backward compatibility. If you are using an older version of C, your program is going to work. So just passing in that single address is also more efficient because of time copying. But if you do this, if you do pass in a parameter that's a pointer is a struct inside of a function, it does have less protection for your data. So some operations in the called function could inadvertently affect the data in the original structure, and this is where you want to use the const qualifier, and you had used the const before the actual type, not after the asterisk, and before the parameter name, before the type. The advantage of passing structure is argument. The function works with copies of the original data. It's safer than working with the original data. So that's really the only time you want to pass a structure as an argument that's not a pointer. And the programming style tends to be a little bit clearer. The main advantage of passing structures as arguments as opposed to passing a structured pointer as an argument is older implementation might not handle the code. It wastes time and space, and it's especially wasteful when you have large structures we have to do. Lot of copying for each member. So keep this in mind. For the most part, you want to pass in pointers to structures, much more efficient and saves times. Programmers use structure pointers as function arguments for reasons of efficiency, and they use constant when necessary. And this is the combination that you want to do. If you are worried about the protection, just use the function pointer for efficiency and then use the const so nothing gets screwed up inside the function, just like really normal pointers more or less. But with pointers it's even more important with the efficiency because of large structure. Passing a structure by value is most often done for structures that are small, and those are kind of the rules you want to think about. Okay, to pass a structure that's not a pointer as long as it's small. Again, some important concepts related to structures and passing pointers as parameters, arguments, and returning pointers as well. Now we can actually start implementing some of this. We provide many examples. We understand the concepts. We understand the syntax. Now I want to present you with a couple challenge that has you actually doing this as you memorize the syntax. That now if you ever wanted to create a structure in the program, you know how to do it like the back your hand. So we are going to have a couple challenge in our next couple section lectures to get you familiar with our first challenge for structures. Let's begin. This is going to help you understand structures, how to declare them and initialize them. So I want you to write a program that declares a structure and prints out its content. We should know how to declare a structure. We use a struct keyword and then we have the tag name. And then inside the structure, we can put different elements. So I want you to create an employee structure that would be the tag name with 3 members in name, which should be a character array. It doesn't have to be a character pointer. A hire date, which is an int, and a salary, which should be of type float. I want you to declare and initialize an instance of the employee type. So you should use destruct, and then you are going to have to know how to initialize members in a struct. I then want you to actually read in from the console 3 inputs: the name, the hire date, and the salary, and then stored in the same structure type of the one that you previously initialized. But before you stored in the type that you initialized, I want you to print it out. So you create your first structure, you initialize it, you print out the contents, and then you read from the keyword 3 more instances of data and put that in the employee type and then print that out. So this is not a pointer. So when you read it in from the input, you are going to have to use the address of operator, things like that. But the rest is pretty straightforward. But this will get you familiar with, again, creating a structure, defining it, and then initializing it and creating an instance of it. When you define the structure, you can define it outside of the main method so that it can be used by any other function. That's typically standard convention. So good luck. This would be pretty straightforward. We will have another challenge to get a little more detail. We'll pass a structure to a function and so forth. But this is just going to have another challenge for you. This challenge is going to be about structures. Again, it's going to get you familiar with elements in a structure that contain a pointer. So you have to allocate memory for that element. It's also going to get you familiar with declaring a structure as a pointer and also passing a structure as a pointer to a function. So mainly structure and pointers in this challenge. So you need to write a C program that creates a structure pointer and passes it to a function. Create a structure named item with the following members: an item name which should be a character pointer, a quantity which should be an int, a price should be a float, and the amount should be a float. The amount that is stored in the structure is going to essentially be the quantity the quantity times the price, because that would be the total amount I want you to create to function. I want you to create a function named read item that takes a structure pointer of type item as a parameter, should be a pointer. We know the advantage of functions taking pointers as argument as opposed to a regular structure, mainly being they are backward compatible. Previous versions of the C compiler didn't work with the structures, and it's also a lot faster and more efficient when you pass a pointer to a function, because you don't have to copy all the elements, you just copy the address. So we are going to have functions that take as parameters pointers to structures. This read item is going to take on what this function should do. It is it should read in from the user a product name, price, and a quantity or an item name. The contents right in should be stored in the past in the structure. So you are passing in a pointer to a structure. You want to store it in there. I want you to create another function named print item. This also takes as a parameter structure pointer of type item. This function will print out the contents of the parameter. So you are just going to do some printfs that will be pretty basic. In the main function, you want to declare an item, basically an item of the pointer structure, or declare an item and a pointer of the structure, because then you can assign to the point of the items the address of the item, and then you also need to allocate memory for the item name pointer. So remember, the item name element inside the structure is character pointed. That means you have to allocate memory for it. If it was a character array, you would not have to, but remember, when you have an element as a character pointer, all it does is create memory for the actual address, the value of that pointer. It does not create memory for what it is pointing to. So if you assign a literal constant to it, it could be anywhere in memory. So you want to allocate memory for that item name element inside the structure. The item pointer should be passed into both the reading, the print item functions. So again, what this challenge will help you with is understanding pointers, how to use them as a point member inside of a structure, and then also how to pass them around. And you have some practice with doing some malloc as well. And then don't forget, whenever you do a malloc, you have to do a free. So make